As a part of the APSC 100 Module 3, we must design an off-grid home for Kim Himani, who is the owner of a countryside property east of Kingston. The house will be located south of Marble Rock Road, backing onto the Gananoque River. The budget is roughly 300,000. However, there will need to be flexibility because of the features and the energy system being incorporated. Some constraints to design will be the restricted square footage or building space, as some of the features wanted is a dining room that seats 10 and a separate music room with noise cancellation. Another constraint will be the topographic surveys that displayed that there's a low-lying nature on the property with a hill and also a river that can maybe provide a risk of floods, which can be a concern. Therefore, an elevated structure should be considered to eliminate the risk of flooding during periods where water levels are higher. The main stakeholders for this project include the residents, developer, Queen's University, neighbors, and the government for housing and land regulations. All these stakeholders will have a direct relation to the design process and will have an impact both positively and negatively. Since the house will be an off-grid home, integrating an energy system that provides sufficient and steady electricity and energy to the home is crucial, and the different energy system options will be discussed. In the process, there are several different designs and energy options that we evaluated to determine the best design and energy efficient option. The first design for the home we considered was a barn dominium, and the second preliminary design was a half A-frame, half bungalow style home. After evaluating the client's requirements, feasibility, energy efficiency, and the space utilization, the best design was a half A-frame, half bungalow. As testing and modeling progressed, the proposed design became more refined. The home was modeled using CAD, and various elements of the design were mathematically modeled. The three energy options we evaluated were propane, solar, wood stove, propane, heat pump, and solar, and propane, solar, and grid connection. After considering each option thoroughly based on energy consumption, cost, eco-footprint, installation, and maintenance, it is determined that the propane, solar, and wood stove option would be the best. By weighing and testing different options, this allowed us to make easy comparisons and figure out the best design and energy system that we should incorporate. This allowed us to have a pretty smooth design process.
The three systems were evaluated using a weighted decision matrix, where each element was evaluated individually. A high overall score indicates that the system is cost-effective, attainable, and efficient, while still remaining environmentally friendly. The criterion was each evaluated as follows. A 10 under cost indicates that the system is inexpensive, where a 1 indicates that it is relatively expensive compared to others. A ranking of 10 indicates that the system is very feasible, where a 1 means it may not be very realistic. An efficiency of rating 10 shows that the system is very efficient, where a 1 means the opposite. Lastly, a 10 indicates that the system is environmentally friendly, and a 1 means that the system will have a negative effect on the ecosystem. As seen in the table, the three systems chosen were a wood stove, solar, and propane, as they are ranked the highest on our criteria compared to others.
After considering the wants and needs of our clients, Kim Hamani and her husband, our team has concluded that a half A-frame, half bungalow style home will be best suitable for the criteria. With this design option, you can obtain 1,400 to 1,700 square feet as outlined by our clients, with no basement and slab on grade to avoid flooding. This design offers an open concept main floor and lots of south-facing roof space for the solar panels that are offered in all three different energy options. As well, in the A-frame side of the house, you get an open concept music room that doubles as a sunroom in the upstairs. And in the bungalow side, you get no lofted ceilings, which is obviously going to cut down your heating costs compared to if you had lofted ceilings. Throughout the entire home, you have energy efficient skylights and windows to maximize natural light coming in, which obviously is going to minimize your use of light and electricity during the day. This home design gives you freedom with shape of the home. You can either make it 180 degrees, 150 degrees of the bungalow coming off of the A-frame, offering lots of different options to get some character out of your home. And you could also put a garage off of the bungalow side. In these pictures, this is the view from the east or west side of the home, depending on which side you want the A-frame on.
Now onto interiors. The figure on the left is an example layout of the home. Example layout of the home. As mentioned previously, it possesses 3 bedrooms, 2 full bathrooms, an open concept main floor with a music/sunroom upstairs. Starting on the left of the figure is the master bedroom with 3 fixture ensuite, guest bedroom, then guest bathroom with laundry services, and to the right of that is the combined open concept dining, living, and kitchen area. With on the right there, where you see the bricks, is where the wood stove will go. Upstairs, you have an additional guest bedroom right when you get off the stairs. And then to the left, once you arrive upstairs, is the music room. Onto our energy solution. Our final energy solution focuses on solar as the primary energy source of the home, with propane acting as a secondary source to power both the furnace and the stove. Using average monthly energy consumption for appliance data, minus the furnace and the stove, the client's expected monthly electric energy consumption was placed at approximately 770 kilowatt hours, or a daily average of approximately 25 kilowatt hours. Incorporating a 20% safety factor, our solar energy system should be able to supply approximately 30 kilowatt hours of energy daily. Assuming you receive 5 hours of peak sunlight per day annually on average, the solar system should capture 6 kilowatts of energy per day. Using the current average Canadian solar system cost per watt, the system cost was estimated to be approximately $18,500. Onto propane. Again, this will only be used to power both the furnace and the stove. Assuming during winter months when they're both running, you can expect your monthly high to be approximately 100 to 115 gallons of propane. As such, we will be implementing a 500-gallon propane tank to allow the clients to go multiple months without refill. The installation of such a tank will run you approximately $2,800. Assuming the propane tank will be filled to 80% capacity, this will cost approximately $1,500 each refill. Assuming that your propane consumption drops by approximately 16% during warmer periods when the furnace isn't running, the clients can expect to pay this refill cost approximately 3 times annually. In addition to both the solar panels and the propane tank, a wood stove will be implemented to potentially provide heating in the winter and alleviate pressure off the furnace and our propane supply. It was demonstrated earlier where the approximate placement of the furnace would be, pretty central to the home. It will possess to get a wood stove, the initial cost will be approximately $600. And assuming you're using it the entire winter, it will use about 3 to 4 cords of wood per year. Assuming you're paying for these cords, they will cost approximately $750 per year.
We evaluated our design solution in 2 parts, the building design and the energy system design. The building design was evaluated using the following areas to determine the success of the structure. The first is that the design follows the regional building codes and regulations. Without getting into too much detail, our design satisfies the required codes, bylaws, and regulations, including the building's forces and required seasonal specifications in the area, as well as the building and room dimensional specifications required in a residential structure. The next is how well the design integrates the client's desired features. Again, without getting into too much detail, the building design incorporates a client's list of desired features. They required a 1,600 square foot home having an open concept living space, 3 beds and 2 baths, 8-foot ceilings, a music studio, and the addition of a front deck. With working within a strict budget, these were considered the major components of the residential structure. In providing the clients with what they need to live, the building's features integration was considered a success. Finally, the house is built within the $300,000 budget, leaving room for extra or unexpected costs, therefore making the building's design a success. Factors during and after the construction were also considered. Such factors include the social and environmental concerns that relate to the development of the property. The rubric states not only the building-specific traits, but also the requirements for the social and environmental factors. These cannot be measured at this time, but such factors include the local residents' thoughts on the development, as well as the possible pollution and contamination of the surrounding environment, and the possible displacement of wildlife in the area. The energy system design was evaluated by the ability of the system to provide energy to the home according to the client's needs and how financially and environmentally friendly the system is. The clients have stated that they wish to be completely off-grid. The solar system, paired with the propane and wood stove system, used an option to meet this desire with room for variance in energy and heating needs. In the off-grid requirement, the design is a success. The rubric in the slide can be used by the client to measure the success of the system. It is modeled for financial and environmental factors. Since the solar system provides energy at no cost after installation, the effectiveness of the energy design is based solely off of the client's usage of propane. With the factor of the seasonal temperature changes and the possibility of hosting guests, the effectiveness may vary.
After some self-evaluation and reflection, our team has identified some areas for improvement in terms of the design solution as well as the project flow. For the design solution, upsizing the bungalow half of the home would offer more flexibility to the clients in terms of layout. It would allow the clients to play around with the flow of the space, as well as would give more possibility for the garage. In terms of project flow, our team would have taken a different approach in terms of planning and scheduling. We would have done some things a little bit earlier, some things a little bit later when evaluating the workload. And handling the obstacles could have used more attention. When handling obstacles, it's important to foresee possible obstacles that may arise, as well as prepare for those foreseen obstacles and adjust to unforeseen obstacles as they come up. And our team overlooked the obstacle aspect of the project a little bit more than would have been ideal. In conclusion, obviously there's a lot more areas for improvement than this, but these are the main aspects that we saw could have used a little bit more attention. Thank you.